This is the first video for 8.2 at 7.2 in the 6th edition, and this is kind of part 1 of ellipses. So an ellipse is one of the conics. So we call them conics again because when we take a cone and slice it somewhere, that's the cross section. So this would be a slice across the middle part that would look like a kind of a stretched out circle, right? In fact, a circle is kind of a special case of an ellipse. So we can also think of an ellipse as a locus of points, just like we were talking about with the parabolas in the previous days videos, right? So in the ellipse, we're talking about a sum. So in the parabola, remember, it was the set of points that were equal distance from a line and a point, and the point was called a focus. Well, in this case, we have 2 points. Instead of one focus, we have 2. The plural for focus is foci, F-O-C-I. So this time we're adding up the 2 lengths. So I had my program show the measure. This is the distance from E to C, and this is the measure from E to negative C. Okay, and you see that we add them up. Now my points are not exact, and so you see that it does vary by a couple hundredths of a centimeter, but you see that it's pretty close. If it were exact, if it were really an ellipse exactly, then it wouldn't change at all. That distance is the same. So we could derive the formula for an ellipse the same way that we did the parabola. It's a little more in depth, and so I don't want to use up the whole video deriving it, because really all you need to know is what the final formula says, right? So when we set up these 2 distances and we set them equal, so well, first of all, this is what the formula looks like. Okay, x squared over a squared plus y squared over b squared equals 1. Now in a is always the larger number, and a is under the x squared, and meaning that it's going along the x-axis. Now this is always a this is always going to be this direction if the a squared, the larger number, is under the x squared. And b tells us this length. So in the next video, I'll show you how it looks when they're switched and the larger number is under the y squared. But for now, we'll just do it looking at it in this direction. So notice that this sum of the 2 lengths is always the same, right? And if I come clear down here at the end, you see that there's just this little section from C to the end that's doubled. Everything else is just 1, and that's the same as down here. So, you know, if I could move that down there, I'd have the whole length. And what that tells us is this length is equal to 2a. Alright, so if I put this right here, notice that each one of these then would be a, right? And so I have this right triangle. This is B, this is C, and this is A. Well, this C is what we always call the distance from the center to the focus. A is what we always call the center to the vertex. B is the center to that other side, the shorter side, right? So this is a right triangle, and it has the Pythagorean theorem relationship, right? So what we know is, we always know that b squared plus c squared equals a squared, because a is the longest. So they're mixed up a little bit from what you normally would think of as the Pythagorean theorem, because we always call C the long side. But in this case, A is the long side. So this is the relationship between A, B, and C. So here's a list of the things that we're always going to be looking for with an ellipse, right? So we have A, B, and C, and that will tell us how far it is to the vertex, the long side, how far it is on the short side, and how far it is to the focus. And the center. In this video, we're always going to have the center as 0, 0. Okay. The vertices, so we're looking for the actual points, right? We find them with A, but those are the actual points. And the foci, which are actual points, so our answers would be in an ordered pair, and we find that with C. Then the length of the major axis, which would be this length from one vertex to the other. This is the major axis. The longest axis is the major axis. And that's just going to be 2A, because remember, from here to here is A, and there's 2 of them. And the length of the minor axis, very similar, from here to here is B, and so there are 2 of them. So the minor axis is always going to be 2B. And then the eccentricity. So the eccentricity is a fraction that tells us how round our ellipse is, right? So if our foci get really close together, and in fact, as they get closer and closer, it gets looking more like a circle. And a circle is when the 2 foci are actually at the same point in the middle, right? Then we have that one radius. Well, the farther away the foci are from each other, the more elongated it is. So the eccentricity is a fraction, and it's always going to be C over A. And notice that if C is really close to A, right, that would be close to 1, but that would mean C is farther apart. So the closer to 1 it is, then the more elongated it is. And if C is really small, because it's close to the center, then it would be more like a circle. So that's what the eccentricity tells us. Okay, so here is an equation with numbers in it. We're gonna find all of these things, and we're gonna sketch a graph. And the graph is really, I do it all along. As soon as I find information, I put on the graph. It helps me figure out all the information. Okay, so first of all, remember that it's x squared over a squared. That's the bigger number, right? If it's 9 is bigger than 4, so 9 is a squared. Okay, so that means A is 3. Okay, this one then is B, right? So there's B squared. So B is actually 2. Okay, so remember, A was the longest side. So it goes A squared equals B squared plus C squared. So A squared is 9, B squared is 4, and I'm trying to find C, right? So C squared is equal to 5, or C is equal to the square root of 5. So C is the square root of 5. Okay, so I'm going to sketch what we know so far on a graph. Okay, so remember that the A is under the X, so the longest side is going to be along the X-axis. And remember the center, I should even write this in, the center is going to be 0, 0. Okay, it's not shifted, and I'll show you what it looks like when we shift it in the third video today. So over 3 from the center, 1, 2, 3, there would be 1, vertex. 1, 2, 3. There would be the other vertex. So I can actually write those down now. It's going to be 3, 0 and negative 3, 0. Okay. Now let's just finish sketching the graph because B goes up this way 2, right? So here is my ellipse. A little wobbly. Now the focus, I want to mark each of the foci, right? So the one of them is over square root of 5, which is just a little bit bigger than 2, so I can mark it right there, right? That's my focus. And I can see that the ordered pair would be square root of 5 up 0. And on the other side, here it would be at the negative square root of 5. Should have given myself a little more room. Okay, so that would be the focus. The length of the major axis, that would be this whole length here, right? And you know that from here to here is A, so that would be 2A. So that would be 6. And the length of the minor axis would be this one, right? And that's B, so that would be 2B. So that would be 4. And then finally the eccentricity is just going to be the square root of 5 over 3. It's just C over A. It's always a number. A is the largest one of the three, A, B, and C, right? And so it's always going to be a fraction less than 1. Alright, so that's what it looks like. That is the whole thing graphed, and we found everything we needed to find from our formula. Here is your quiz question for this video. So there are 2 questions, and I gave you the formula for an ellipse. It's very much like the one we just did. I want you to tell me what A is and what the vertices are. So when you write the vertices into the quiz, write them as ordered pairs with parentheses and just separated by a comma, and don't put any spaces anywhere. Alright, you can find all the rest of the stuff that we also talked about if you want, and sketch a graph, and that might help you figure out the vertices, but those are the 2 things to enter into the quiz.